Hello. Sorry I'm out today. I've been coughing, and based on recommendation from along with the sore throat, based on recommendation from administrators, they said probably better stay home. So, anyways, this is a video that would we would have done in class and had a little bit more discussion on, but that's okay. What I have here is I've got a vernier microphone. So basically it picks up sounds. I could show you, it goes really quick. So there, pick up sound. Basically what it does is it measures the sound pressure. And what it does what that means is when we talk about pressure, we're talking about particles colliding. Okay. So when it's a higher sound pressure, that means there's more particles colliding. When there is less pressure, low pressure, that means there's less particles colliding. And sound waves are waves moving through air. So that's basically what we're talking about with sound pressure. It's a way to measure the fluctuation of whether air is really compact or whether it really spread apart. And if you remember, we talked about, we mentioned this the other day, two types of waves, the transverse and the longitudinal. Okay, longitudinal force applied this way, and the wave is also moving that way. That's what sound is. Okay, and so what we're seeing here is an up and down pattern based on really compact parts and really spread out parts of air. That's basically what we see. So what I have here is a cell phone, and on that cell phone I have an app called a frequency generator. And so basically, I don't know if you can see it, but yeah, at the top, frequency is 400 hertz. I can play a little sound. Can you hear that? Let me turn off my air conditioner. Hold on. There's the sound at 400 hertz. I can change the frequency to about 500, and it sounds a little bit different. Okay. So what I wanted to show you was a simple little thing here. I'm just going to collect data here. I'm just going to hold it up to the vernier microphone. I'm going to hit collect. Boom, and there we have it. Okay, and so notice that it's an oscillating high pressure versus low pressure, high pressure versus low pressure. Notice it's the same every single time. Okay, now one thing that you should probably know is that on the x-axis here, this is time. Okay, so it's time, it's not length. So I couldn't measure from this peak to this peak and get the wavelength like what I did in that simulation, because it's not a length, it's a period, it's time. Okay, so anyways, I can find the time for one revolution here, like so. I can measure it like that, and I could find that period. Okay, I'm going to store this latest run, and it'll just kind of stay in the background. Okay, the most obvious thing that I could probably do, the question that you guys are trying to answer is how can I change the amount of energy? And you guys, a lot of people said frequency, which we'll look at in just a minute. But maybe, perhaps, on a cell phone, how could you get more sound energy? Well, you could turn up the volume, right? So I don't know if I have it all the way up. There we go. This is going to have more sound energy, right? Like that wave will have more energy because it sounds louder. This will have less energy because it is quieter. So I'm going to do one really, really high. I'm going to hold it at the same position here. I'm going to hit collect. Okay, maybe try it again. There, that looks perfect. Okay, let me pause that. What's the difference between the blue and the red? Well, if you notice, the blue goes up higher and down lower and up higher and down lower. Basically, there's bigger range. So what do you think is going to happen if I go at a quieter volume? Let me store this. Store latest run. Boom. We'll go really quiet. Boom. Perfect. So the green represents the quietest run. The red represents like the in-between volume, and the blue represents really loud volume. That's very clearly an energy change of that wave. So what's changing about it? Is the time between each cycle changing? Let's check. That is a difference of, you can see down here, of 0.002 basically from the green. Let me find a red one. So from red peak to peak, it's 0.002 again. And then from blue peak to blue peak, boom, it's 0.002. So in other words, the volume does not change the amount of time in between each cycle or the period. Instead, what it's doing is it's changing how high it is, or the amplitude of that wave. So therefore, energy can be thought of as changing the amplitude. So how do I want to have a more energetic wave? I need to have a bigger amplitude. That's the answer. Okay. So now you guys said frequency could also impact the energy of the wave. So let's just see this real quick. Okay, let me go just new experiment here. New. Let me play one at 500. Again, I'll go fairly high with it. So there's one run. I'm going to go data. I'll go store that run, store latest run, and now I'm going to go increase the frequency. So let's say I double the frequency. Okay, I'm going to go 1,000. Okay, so instead of 500, I'm going 500. Oh, that's very annoying sound. There, boom. Oh, you know what? I probably messed this up. I probably should be holding it constant as to how far away it is. But let me try it again. Well, anyways, what you can see here is that it's very clearly oscillating faster. In other words, notice how this part right here is actually pretty good, okay? Because I'm going from a red peak basically to a red peak. And how many peaks are there for the blue? There's about 2. So if I doubled my frequency, then that means there's going to be 2 peaks for every 1 peak of the red. You'll also notice that the amplitude does seem to increase a little bit here. So maybe there is a little bit of energy associated with that frequency. Although I'm curious as to whether it is associated with the phone volume when you switch frequency, because generally frequency will not change the amplitude of the wave. They're independent of each other. So the answer to what causes energy of a wave is the amplitude. So frequency generally does not change the amplitude. I probably need to do something more convincing to you guys to prove that to you. But just for now, just accept the fact that amplitude is unaffected by the frequency, and amplitude dictates energy. So now at this point, you will go on to the next page. You'll start working on basic things of the wave. There's very basic principles there about wave properties and things like that. I want you to go ahead and work through them. You may or may not be able to answer all those questions. Do your best. And you may be unsure. I just realized I have an open cabinet behind me. That looks super trashy. I'm sorry. Anyways, so if you guys have questions, let me know. But do your best on that worksheet. We will discuss them on Monday. We also will finish a discussion, and I will talk to you more about the independence of frequency and amplitude. So, yeah, that's it.